Master, and we're going to be talking to you about robot operating systems, ROS, right? And this is conducted by the Autonomous Robotics Club. I'm assuming most of you here are from ARC. How many of you here are not from ARC, from outside of ARC? Yeah, 1, 2. Ask Robotics guys, you guys can raise your hands as well. So 1, 2, 3. Okay. Yeah, I'm assuming most of you are from ARC here. But yeah, if you have the Notion open, how many of you don't know where the Notion is, or don't have the Notion pulled up? The link is bit.ly, like bit.ly, /arc-ros. And I don't know if you can see it, but it's right up there. But yeah, so we're going to be just talking through this entire Notion page throughout, because we just documented everything for this workshop on Notion. And it's also available for you after the workshop is over. So once you guys are done, you can still access this page and still refer to like links, documentation, and whatnot. So yeah, I'm not really going to go into the about ARC. I guess I'm assuming you all know who we are. We're one of the largest robotics clubs on campus, and we do have 6 active projects right now, and we run project meetings every week. We have social events and workshops, and this is the first one this semester under workshops. So let's get started let's talk about who we are. Just the two of us talking to you. The other ways, okay. So yeah, my name is Revanth, and I'm the vice president of ARC. I'm also the project manager of Piano Hand. I do see some of y'all from Piano Hand here as well. That's awesome. And there's a simulation sub-team in Piano Hand which primarily uses ROS as well. And that's kind of why I made them come here, actually. I'm like, you're going to have to learn ROS. So simulation sub-teams here. Along with that, I also do research here on campus, robotics research, where I work with quadrupeds. Have you heard of the Unitree Go 1 robot? I use ROS on that as well. I also listed a bunch of other robots in the past that I've used ROS with. So I've been using ROS for a while, and I felt like it also helped me get a job for this summer, just learning ROS and understanding ROS as well. So I just feel like it was an integral part if you want to get into robotics, and literally any robotics software engineering role you apply to, it probably contains ROS as well as a requisite. So yeah, and research too. Most robotics research today, you're going to use ROS one way or the other. So yeah, I'm going to pass it on to Campbell to talk about it.
Hi, I'm Campbell. I'm the project manager for Rocket League, one of the projects in ROS. What we're doing is making Rocket League in real life, except the cars are autonomous, right? They're playing soccer against each other autonomously. And that's very difficult to do without something like ROS. So we use it a lot in our project, and it's something that we've always wanted some sort of good onboarding process for, to get people learning ROS as soon as they can, because it's stuff we use in every meeting. So we use a lot. And then I've also worked in the past with ROS a little bit in high school on something called F1/10th, which is like scale RC cars that go around a track and also use ROS. So I've got a good bit of experience with it.
Awesome. All right. So yeah, let's get into a little bit of background, right? How many of you here already know what ROS is, or have used ROS, or at least tried to use it, right? Okay, there's a fair amount of you. Okay, but yeah, what ROS is, it's robot operating system, right? It's the software backbone that connects every single component that you have on any robot that you can build, right? So and today in industry, so many companies deploy and use ROS, and there's a reason for this, right? ROS it's not just some hard software backbone that makes everything complicated and makes it harder for you to debug robots, right? ROS helps you interconnect systems, right? Let's say you have the robot in the display over here, Turtlebot right here, right? So this Turtlebot has not just its controller, it also has cameras, it has a bunch of other sensors, perception, has the environment it's navigating in, has so many different things that it needs to process as it's moving around the environment. So ROS gives you that framework to put it all into like one system and make it easier to like think about processing and using the robot. So, couple things. Oh, my bad. Okay, yeah. So, couple things before getting into this, right? We want to understand what, that ROS is open source. It's free to use. Anyone can just download, install ROS, and use ROS. So there's no like actual cost dependency for even though companies use it. It's meant to be free of cost. It's for anyone to like deploy and actively contribute to the community. And this is one company called Open Robotics. They're the ones that maintain and make updates to ROS every once in a while. And yeah, today for this specific workshop, we're going to be introducing you to something called Construct Sim. That's right here. So if you want to go ahead right now, you can just click on it and log into Construct Sim, and we can just go over it right now. So when you open Construct Sim, this is what it's going to look like. It's going to ask you to log in. You can just log in. So yeah, before you click that, let's just wait. So yeah, so let me know if you guys have logged into Construct Sim. Once someone's still logging in, we can wait for a bit. Is everyone good? At the back, too? All right, so once you logged into Construct Sim, you want to click on My ROSjects. So Construct Sim this is one company. I think it's based out of Italy. I'm not exactly sure. It's one of the European countries, but they basically have a bunch of courses. They have webinars and everything on ROS, and they're pretty popular too, at least on YouTube and the internet on like ROS stuff. But the coolest part here is they have this thing called My ROSjects. So if you go to My ROSjects, you can create your own ROSject. So let me do that with you, right? So go ahead and hit create a new ROSject. Oh, I'm not sure what. Sorry. Yeah. So under ROS distro, you want to hit Humble. So it's ROS to Humble. You should find right here. It says ROS to Humble. We'll talk a little bit more about the versions of ROS and what distro to use and all that in a bit. But for this workshop, we're going to be using ROS to Humble. That is the current active, most supported, I'd say, ROS 2 environment out there. So I'm going to click on ROS to Humble. You're just going to give it a name. I'm just going to call it ROS Workshop. ROSject for ROS Workshop. So yeah, it's just a simple ROSject. So once you have a ROSject is just a ROS project on construction. It basically lets you emulate ROS completely independent of what your PC's environment is. And it just like runs a version of Linux in a virtual machine that lets you like, what do you call, run all ROS commands, run like all the simulation, the visualization stuff on ROS just from the internet. So let's go ahead and create this. And once you hit create, it should show up like as one of the ROSjects right here. So you can go ahead and open it if you want to right now, but I'm going to go back to the ROS background because you're going to be using that specific ROSject throughout this workshop. So yeah, some real life examples of companies like that use ROS. There's a whole we found a whole GitHub repository of just companies that use ROS actively. And yeah, like these companies actively recruit as well for jobs for people who know and can use ROS as well. So yeah, that's just a little bit about the ROS background. Do you guys have any questions so far about what ROS is? And I guess we'll go more into like how to use ROS, but do you guys have any questions on the ROS background itself? None? Okay.
All right. So ROS, for the most part, runs on something called Linux, which is an operating system. If you're not familiar with that, it's like if you've got a Windows laptop, Windows is your operating system. If you've got a Mac, Mac OS is your operating system. It's what your computer runs. Linux is another operating system, and that's what most people use ROS or run ROS on. There's a few things you'll want to know about Linux before you get to work, so we'll go over some of that. When we're interacting with ROS, for the most part, it'll be through a command prompt, which that's not running. I'll show it in a minute. But it's like a text interface. You type commands, you get data back. If you ever have a command that you don't know, you can use that man command, short for manual. When you are using, hopefully, no, ignore. I'd really like to get a demo. Okay, well, wait a minute. When you are in your command prompt, you're pretty much navigating through your computer, so you can be in a specific directory at a certain time. You can change directories, you can move around. There's some shorthand you can use to get to different directories relative to yourself. There we go.
Okay.
Right, command prompt, if it loads. I'll keep going down. Most of this stuff you'll be able to you'll just want to look back at as like a reference. PWD prints your current directory, so if you ever don't know where you are, you can use it to. No, still?
Yeah.
There we go. Look at that. So that's my current directory.
You want to zoom in.
Yeah, it's not a bad idea.
So.
There's also.
It is called web shell, by the way. On.
Oh.
Yeah.
It's the bottom thing over here.
Yeah.
That's how you get to your command prompt. ls is another one that lists the stuff in your current directory. It'll highlight things blue if they're another directory, or if it's just a file, it'll be white. If you need to make a directory, this is one we'll be using a bit. You use mkdir, make directory, right? You can use mv to move stuff around. rm, and again, I know I'm speeding through this, but it's just a bunch of acronyms and stuff, so to make sure you actually know it, you'll probably want to go back through and read the specifics. I can do demo though. Let's say I want to make another workspace. We'll call it workshop workspace. So I just made a folder, and then if I want to go into that folder, I can use a command called cd, and then we'll start with ls, so you can see it's there, right? And now I'm inside it. And there shouldn't be anything there because I just made it, so it's empty. If I wanted to, I could remove the directory, but since it's a directory and not a file, instead of using just rm, I'm going to use rmdir. Now you can see it's gone. Right. Two more important ones. So when you're in a command prompt, you've got a bunch of commands, right? Let's say you've got a list of commands you want to run every so often, but you don't want to have to type them in every time. You can put them in a file. You can make a script. And when you do want to run that script, you'll see that we're using a command called source, and that runs the contents of that file in your current terminal. I don't have an example for that, but... Okay, last one. Do we even touch Nano?
Sure.
We'll just use the code editor.
Nano, I guess. Okay, so do you want to? We can just go through the next one, and Nano, we can come back to it.
Yeah, that's fair. There we go. Is that you? No, that was me.
Yeah.
So we're going to move on from Linux for now and actually get into ROS. One of the reasons we're using construct sim is that like you don't have to actually install anything when you use construct sim. You just create your VM and everything's already installed. So you don't have to worry about like installing ROS, installing libraries or anything. Everything's already there. Here are a few so remember we were talking earlier about how Humble is the current supported ROS distro, or ROS version. There's a bunch of other versions. ROS operates they have an LTS version, short for long-term support, and they have a latest version, which has like the latest features, latest bug fixes. But for the most part, you're going to be using the LTS version so that you can have your project running for like years at a time. We don't need to install because we're using construct sim. Yep.
So yeah, if you, since you're using construct sim, you can directly skip to step 3 on setting up like getting started with ROS.
Everyone should be using construct sim.
Yeah.
Okay. Yeah, we'll get right into that.
Do you want to talk about ROS checks a little bit? I guess. I mean, it's fine.
Oh yeah, I'll like go through the interface. So. On the ROS check page, remember that we used this button over here to make a web shell. You can do that again to get 2. There's other things. There's a code editor, which if you're familiar with VS Code, it's almost exactly like that, just slimmed down a bit. There's also a few buttons over here. Gazebo is a tool we'll go over later. Just remember where that is. This one's where you get so it looks like we're on a desktop, but we're not really on a desktop. It's still just a web page. This is the tool you'll get to actually see the desktop of the computer you're connected to. Don't need that. Cool.
Yeah, you can just close that if you want to. Yeah. Let's go.
There's that source command from earlier. Once you've got your web shell open, I'm going to go ahead and close everything. That's a lot. Nope. There we go. The source command from earlier. So there's a bunch of commands in Linux, right? There's also commands for ROS. You'll see that if I want to type ROS2, it'll say command not found. That's because to actually start using ROS, you need to run this thing here. What that basically does is the commands that are in setup.bash set up your terminal to use ROS. So you have to run that before you want to do anything. There we go, ROS2. It's slow, but it's working. Right,
yeah, that should be the output.
Okay, it's slow. But point being, that's the output I would get. It shows the usage of the command, and usually if you've got a command you don't know how to use, you can just run it without any arguments. There we go. So what I'm going to do now is I'm going to run 2 demo processes to make sure that my ROS install works. I'm going to start with that one, and it should start talking. There we go.
Yeah, we'll talk a little bit more about what those are in a bit.
The important part is that you just make sure that you can see the publishing Hello World 1 part, and it'll keep incrementing. If you don't see that, go and raise your hand. You should be able to open a new terminal with this plus button over here and run the second line in from Notion. Right. So what we're looking at over here is mostly self-explanatory, but we're seeing 2 processes in ROS talking to each other.
Yeah. So, like as Campbell mentioned before, one is a publisher, the other is a subscriber. We'll talk more about that in a bit. But this basically shows that your ROS environment is working and that you can see that something's running, right? So now we're going to test one more thing, right?
I don't know what I did. Okay.
Yeah.
Point being, another Linux trick is when you've got something that's running like this and it's on a loop, you can use Control-C to kill it. Back to So we're going to try another thing that'll show you, it'll get you used to the virtual desktop I was talking about earlier. There's two commands on the Notion, run both of them, again in like separate terminals and stuff. Oh, wait, that's the wrong one. Come on. There we go.
Yeah.
So if I wait for a minute, there we go. You'll see right there.
Yeah, I'm not sure if you can zoom in to that. Can you?
I can expand it maybe?
Try that. Okay. Basically, what that did is it launched a turtle sim, or like a small turtle in a simulator. And the first command was just to launch the turtle sim. You can't really like control the turtle or anything. The second command, do you want to go ahead?
I'll run the second.
Yeah, run the second command. Actually, zoom out. So, like, you don't want to use the full screen because that's fine. You can just The second command is going to let you use your keyboard to control the turtle with your arrow keys. So now I guess you need to move the terminal.
I'm gonna do this. You can't really see it because it's a bit small on my screen, but
You can move the.
let me shrink that.
Yeah. So you just use the arrow keys. So can you see it? The turtle is moving. If you use arrow keys on the other terminal, make sure your cursor is not on the turtle screen, but it's on your terminal. So you're entering input to the terminal and not the turtle itself. We can just come around and see if you guys have this set up so far.
Yeah, I did. Oh, so would like shrink the
If you're having trouble making sure that you can see both windows at the same time, there's a little thing in the bottom right corner you can use to click and drag to change the size of the window.
Yeah, I don't know if that fixes it. You have to go to vertical and then you have to this one, right? You should be so you're on the vertical way. So you might like because you stand next to that. Oh, I see. That is very weird. So it's that's the vertical sense, right? Yes, sir. I wish them up from React. How did it go, by the way? Did it work out? I don't know. Huh? So my PHP is sucked. Like, GAMP didn't work. GAMP didn't work. Oh, okay. I don't know which one was it. That was weird. If you're using the constructs and you don't have to install. I don't know if that's alright. Yeah. I'm over here. I actually looked on ice and I think I hit my leg. This music hurts so bad. Luckily, for me, it was just like it wasn't a slush, but it was like kind of salty, so it got a little bit in my pants. No, I already did it. Campbell. Oh, okay. Yeah, it's all messy though. That's like that's. Oh no, no, dang. I heard so much today because I need to get. Oh, when you we can start like this. Last night I watched a 2-hour-long movie called Bullet Train. As soon as I got out of the shower, I didn't dry my hair while I was watching it. This is what happened. Yeah, same. Like this. I made food with my towel in my hair. I was making a whole like freaking meal like. You feel it's such a chill vibe. It's actually pretty cool. I never used ROS for any of my projects. I don't need to either, but I just want to. I do. I mean, but I don't know. I don't think the reason I was actually considering doing robotics as my career, like as an actual career, but it just doesn't have the same feeling as like web development. So it's kind of tricky. One thing I don't like math as much as I do software. You make mistakes. Calc 1, Calc 2, Calc 3, you. Linear. Yeah. And then what else? You just take more math. That's bottom line. Okay. That's for like for the data, right? For data classes. Oh yeah. Oh, you're not doing the software track. Okay. Yeah, that was one thing. I'm not a huge I don't like math. Another thing was I know a lot of like the introductory CS stuff. I don't know much about IT and systems infrastructure. I would literally hire like when I was working in San Diego, I would hire like offshore devs to work with me on some of the IT stuff because I didn't have no clue what I was doing. It's like deployment. I'm still so shit. You know how like so there's something called PM2. It's like a professional like a Node and Linux deployment system production. I have no idea how it works. I'm gonna learn it in my like because it's infrastructure, and I want to learn about all of that. So that software, I can maintain it, I can speak to both. That was sort of the and so, they're both very similar. I think the architecture is wrong. I love it. I'm saying I love it.
Video? Yeah, and I rubber banded two servers together.
Campbell.
Which one? Oh, yeah. Right now we're doing circuits. I'll bet you mine isn't. He's by his hell. Yeah.
Okay.
We're now tracing circuits.
I'm assuming you guys have Turtle Sim running. And can I get a show of hands if anyone doesn't have Turtle Sim running? Okay, everyone has Turtle Sim running. Okay. Let's move on to the next step. Okay. All right. So now that you've basically set up your ROS environment and you're able to like use ROS now from your workspace, let's go to the next step, which is how do you create a ROS workspace? This is something that's very crucial because this kind of dictates the flow of your project. of any robotics project you're working on. And if you don't have this set up the right way and don't have the right file structure, it's going to make things very hard for you to debug, and it's going to make things like really hard to like understand when you're like when you have bigger issues with the ROS workspace. So first off, you might have run this command before, right? Do you all recognize this command, the source command? The humble setup.bash. So you need to first make sure that you've sourced your environment, like your source your ROS environment. But it might be hard for you to like just keep sourcing it every single time you open the terminal, right? So there's this thing called a .bash rc, which is a file that gets executed every time you open a new terminal. And if you add the command to the end of your .bash rc, you don't have to worry about sourcing it every single time. So in ConstructSim, they've already done that for you. So we can just take a look at their .bash rc real quick. So I'm just going to stop these terminals. Okay. So I'm going to use a command where I can view a file. This is called cat. And this will show you like what the .bash rc looks like. You don't have to run this command, it's totally fine. But I'm just showing this so that we can see that they have, where did they have it sourced? Okay, ConstructSim is a little, okay, it's fine. ConstructSim is set up in a different way, so it's totally fine. But when you're developing ROS on your own computer, you basically just edit the .bash rc file using this command and add this command to the end of the .bash rc file. So every time you open a new terminal, it's just going to run the source command. Let's move on. So we've used this word workspace quite a bit, right? And you might be thinking, what is a workspace? So if you hit ls on your home directory, you'll find some default workspaces. It might be named different for you. It might be named Catkin workspace, or it might be named whatever, right? But a workspace is basically the directory with which where you're going to put all your files. Everything from, you know, like launching Gazebo, creating controllers, reading sensor messages, everything is going to go into your workspace. So let's go ahead and look at how we're going to create a workspace. As I said before, a workspace is just a directory, right? So you're going to make a workspace the same way you make a directory. You could just make a directory and then create like a source file inside of it and do whatever. Or you could just combine it all into one command with this make dir -b my workspace source. The -b command, all it does is it initializes the workspace to something called an absolute path. It's basically the path with respect to where you are right now, from like the home directory or whatever the root directory is on your computer. Instead of saying, let's say you want to move to a certain directory inside of the directory you're in right now, inside of the Linux environment, it's going to say this is actually, you know, /home/ whatever it is. The full path of the actual directory is going to be like referenced inside the Linux environment. So you just use this little make dir -b. I'm going to call it my workspace. Let's put that in here. And what this is going to do is it's going to create a new directory called my workspace. It also is going to create a source directory inside my workspace. That's what the /source means. So if I cd into my workspace, you'll see that there's a source directory here. But something that's very important with ROS is inside a workspace, you're supposed to create your own source directory. Else the thing won't build. Else your workspace will not build and you won't be able to like make any, what do you call it? You won't be able to like run any scripts, right? My source directory is empty. I've just made an empty source directory, but that needs to exist for a ROS workspace to build. So how do you build the workspace? I've already cd'd into my workspace, and now I'm going to build, right? So this is colcon build. I'm going to just run colcon build. and you'll see there's 0 packages, but it finished, right? There's no errors, it just built the workspace. Now what's going to happen is if you ls, you're going to see a bunch of new directories called build, install, log. Sometimes the log directory is not created. It depends on the environment, but here we have a log directory as well. We're not going to touch the log directory at all unless you have like errors that's impossible to debug. So now you have build, install, and log. What are these, right? These are just binaries that exist that need to like that contains information on, how exactly you built the workspace. What are all the variables that need to exist, right? So again, this is another like environment within your ROS. Like this is another like separate, entity that ROS needs to worry about, right? So what we're going to do is we're going to source this workspace as well. So there's something inside or install. I'm just going to change directory to install to show you what's there. You'll see a bunch of these shell scripts and some Python files and whatever, right? But this setup.bash is very important. Setup.ps1 is for PowerShell. Setup.zsh is for another version of a terminal. .sh, you can use that with Mac OS as well, also for Linux. We're going to use setup.bash. That's the most common. So we're going to go back to our workspace directory, and we're going to source install/setup.bash. This source install, you need to run it in every new terminal that you're running your ROS environment on. So even if you, let's say I open a new terminal now, right? I have to source, if I go into my workspace, I have to source it again in here. So if I'm going to be like running a script here as well.
If you remember how we had the source from /opt, I think, earlier, that we used to set up our terminal for ROS, this one sets up your terminal to use your ROS packages that are inside your workspace. It makes ROS aware of where your code is located.
If you don't source the setup inside or install, you're not going to be able to access the packages and nodes from within your ROS workspace. So all this we've put inside the Notion. You should be able to like take a look at it. Colcon build, there's a little bit more about this. If you're interested, you can go and read it as well. You can even select specific packages to build and not build all the packages in the workspace. That sometimes can be like, let's say you're like still fixing something, another package is broken, but you want to just test the functionality of another package and you want to see if that's working. So you can just select a specific package. Or let's say you didn't make any changes to one package, but building it's going to take a long time, right? So you can just leave the binaries as is for that specific package. You can just build select package that of the specific packages you made changes to. You'll understand what this is when we get into like creating nodes and creating like publisher, subscriber, and all that. We'll go through that in a bit. But this is the basics of getting your workspace set up for using ROS. So you do want to know that ROS is not perfect, right? It can be buggy. So sometimes it might just happen that the first time you've sourced the environment, it didn't source it completely. It's a very rare chance that it happens, but there might be issues where it doesn't recognize a certain package, but even though you source the environment with the package in it, you want to double check and make sure you just source it again. Sometimes sourcing it twice makes it, sources it better, I guess. But just to say that this source command here, it's not perfect, right? You might have to run it twice sometimes if you run into errors. Right? So what do you see over here? This is one of the most important things when it comes to using ROS. It's your file structure, right? You want to use the right file structure when it comes to, whatever package you're using. All your packages, everything in yellow indicates stuff that you need to make or you need to create. Everything white, those are just stuff that when you like run colcon build, they just show up in the workspace. Something we didn't mention, I think there should be CMake lists as well, cmakelist.txt.
We'll get to
Yeah,
that.
we'll get to that. So, yeah, there's going to be other files as well that are going to be created when you create a package. We'll go over that in a bit. But just remember that whenever you're creating a new package or making something, like getting something from a Git repository and putting it into your workspace, you want to put it inside the source directory. A separate package needs to go inside the source directory. You can't leave it in the workspace. And ROS is going to get confused sometimes if it's just in your workspace, and it's going to cause more errors. So, yeah. And yeah, we have a little link here for just creating a workspace if you want to go a little bit more deeper into like creating a workspace. So we're just going to move on to the next module. This is going to be the longest.
This is where we're talking about actual ROS concepts, the meat of it all.
Yeah.
I'm going to start with, so up top we've got a diagram that probably doesn't make much sense right now, but as we go down this page, you'll start learning about the different concepts displayed here. And you can see one of them is node, and that's what we're going to start with. So a node, right, so ROS is really good at passing information between different processes, right? That's what it's used for the most part. And a node is a participant in that graph of information flow. It's code you've written that uses a client library to talk with ROS. It can communicate with other nodes through ROS. There's a command right here you can see. A node is pretty much just we'll be doing Python, so it's just a special Python file and a special location. And you can run it with this command to make sure that it's connected to ROS.
Don't run the command just yet. That's just like it's a template to show that's how it's gonna.
Right.
Yeah. Oh, sure, yeah. So, yeah, messages. If you looked at the first graphic, messages are basically what's being transmitted between each node, right? That's what messages, I'd say, simply put, messages are just ROS data types. Like, you have your standard integer, string, float, tuple, whatever that is, right? Messages are simply just ROS data types. And there are many kinds of ROS messages. You can see standard messages, geometry messages, sensor messages, so many different kinds. For example, geometry messages, you can contain information like pose. Let's say like you're representing an object in 3D space, has an X, Y, Z, and a roll, pitch, yaw, right? Or you can have a quaternion, which is another angle representation for an object in 3D space. So those kind of stuff will be a part of geometry messages. Things like IMU data, your ultrasonic depth, all those are sensor messages. Those are going to be in sensor messages. And yeah, you can go through this link. That just includes a bunch of like common messages. There's also documentation on what kind of messages are included inside each of these. But messages are described and inside this thing called a .message file. So if you remember the file structure, there's this thing called a message directory. So inside this message directory is where your .message files are going to go. And when you source your ROS environment and include the right, right directories inside your, right includes in your code, you should be able to just use these messages when you're like creating like a node, creating a publisher, a subscriber, whatnot. So that's, what else do we have? Yeah, I mean, there's one more thing about constants. So this is the way you actually, like, declare like a simple message. So that'll be like, I'm sorry? Yeah. So you'd see a type and then you'd see a name. This is just like a variable name, and then this is the type of the variable inside each message. And you can also, just like any programming language, you can just make these constant by using like an equals operator. And setting them equal to something is just going to be like, if you're going to use the specific constant multiple times in your message or multiple times in your code, or across different nodes, the value doesn't change if it's the same. It's just going to store that in this format. So yeah. Oh yeah, I mean, yeah, there's also like documentation on how to create your own message, because if you're creating your own message, you need to modify like some other files in your ROS environment. We don't want to go too deep into it because it can get a little complicated. But if you just follow documentation, you should be fine. Yeah.
The ROS documentation is really good, so if you've got any questions, you can just go to one of these links and look at the sidebar. You'll be able to find what you want. So remember, going back to this graph, I mentioned that, okay, node can talk to another node, but how does it know what it's sending? So if node A sends node B a number, how does it know that that's like the speed of the robot? Well, you can do that using something called topics, and topics are almost like channels on a radio. So you can have like each node listens to a different topic and knows that, okay, when I get a message on this topic or channel, that data is for the speed of the robot instead of the rotation of the robot. And topics also have, so we just talked about messages, the data types, right? Each topic usually only has one message type. I've never used it in any other way, at least. But that's what we're going to focus on for now. Topics, right. So we've been mentioning publish, subscribe a lot. ROS is a pub subsystem. Each node will publish messages, so it'll submit data to a topic, or it'll receive data to a topic, or it'll do both, so it can like work with that data, put it somewhere else, send it to someone else. Right. Something about ROS is that so it's, again, I guess pretty similar to radio in that like when I publish a message or when I publish data to a topic, most other nodes don't really care where that data came from. You can figure out where it came from, but for the most part, it'll be like a radio where you hear a message, and unless someone says who it's from, you don't know who it's from. It's just a message.
Yeah. So one of the biggest, I'd say, advantages of using ROS is something called ROS bags, right? The first time I was introduced to ROS bags, people just told me they were videos, ROS videos, and I was very confused, right? But like working with it quite a bit and understanding what exactly they are, like now you can kind of like think about ROS bags as a timestamped recording of every single thing that happens on the robot. So let's say you have a bunch of different links on the robot. There's a bunch of sensors, there's camera data. There's also like something that stores the time that it takes as it's performing a certain task. A ROS bag can basically record all of that information with timestamps. So you can, for example, let's say you're using a drone, right? You can find out exactly what the angle of the drone was in yaw or whatever when it detected a certain object in the environment. So at that specific instance, what was the drone doing? Or let's say another robot arm, right? It gets some external disturbance to move around, and then at that moment, what were the groupers doing on the robot arm? So you can get like a sense of how the robot is reacting, what exactly is happening on every single part of the robot with ROS bags. And ROS bags, you can record ROS bags using a simple command called ROS2 bag record, and then you can select whatever topics. But what's important is ROS bags are heavy. They can, like in the past, I've used the Boston Dynamics Spot. There's so many like, topics and nodes on Spot, right? And if you just list all the topics, it's gonna extend to more than 2 terminal windows, right? If you record all of that for even 10 seconds, it can come up to like 3 gigabytes of data. So that's a lot of data. You want to select exactly what you want from the robot. You want to select like a specific camera, a specific link, or a specific sensor. And ROS2 bag record lets you like select those specific information. But it is very important to select those. But what's beautiful about ROS bags is you can just record a ROS bag, and later someone else who doesn't have access to the robot, or you yourself, if you don't have access to the robot, you can just play that ROS bag that you recorded and emulate exactly what happened in that situation. So it's going to contain all the data recorded, and you can still like simulate what happened with the robot. If you record those simulated topics, you can still like simulate all that as well. And you can just work on it with whatever project you're working on. So yeah, ROS bags, you cannot do this with any other framework other than ROS, because it's going to make it harder. If you have an individual, like let's say you're like recording individually each camera, each timestamp and everything into one, and then trying to like match the timestamps, that's going to, one, be inaccurate, and two, it's going to make it harder for you to like put it all into one system. So it's by far one of the biggest advantages of using ROS is ROS bags, and especially for data collection, it's going to be very, very useful. Yeah.
So I've already gone over this for the most part. You remember you remember that publishing and subscribing is anonymous for the most part, right? A node doesn't where its data came from. But I also talked about how topics in ROS can be like each topic has its own message type, and we call that strongly typed. All it means is that you can only send this one type of message on this topic, right? You do services? Or
Yeah.
you do services? Okay.
Sure. Yeah, services. Services are basically a special way of, I'd say, it's a, let me go back to the graphic, right? It's probably easier to explain it this way. Think of a service like a client-server, response system, right? One node requests a bunch of data from a service, and then the service is like, it looks at it, it does some processing, and then it sends the data back to that specific client. Same thing for a server as well, a client server. You can think of it just like a client server methodology. The service is the hub that controls communication, and everything that transmitted between these they're technically messages, but in ROS, since they can be represented as a variant of messages, they're just called services. And you can still use like, you need kind of like two message descriptors in one service definition. So if you think about this, everything above the 3 dashes, that can be thought of as one message. Everything below can also be thought of another message. So one is like, it's like a client server system. So one is like a response, and the other one's like a,
Response.
yeah, column response. Yeah, what's up?
So how are they different from like topics and like the messages that you see like set through topics? Like what is it like if I was spending like speed or like velocity values and stuff through like some topic, like what kind of data would I be seeing sent through like a client server?
Yeah, sure. So the question was how are these services different from actually using topics, right? And simply put, there's no direction constraints for services. So topics are always point A to point B, and if it's a topic, it can only, like, if you have a message from a topic, you just go from node to topic, and then the topic distributes it to like other nodes, and it's defined, right? So you need one publisher and one subscriber, and that's how like topics work. Or you can have a publisher and a subscriber in the same topic, right? But with services, it's a client-server system. It works on the basis of responses and requests. So if one node requests a certain service, it can either like it can even send a message. It can get back a message. It can go back, and it's more of like when you have a system where there's like back and forth communication between two different components, and services make more sense to use. Yeah. And yeah, there's more documentation here on services. You can just read more about it. And yeah, you can just...
Over here, we've still got that same file structure example from earlier. You can see, okay, that's where service files go, the .serve files. And we've got the message directory, everything else we went over. I'm not going to touch on that till later.
Yeah.
Right, should I do launch?
Yeah.
So going back to the top, we have nodes, right? And there's this command here that's ROS2 run. And I said, okay, that's how you run a node. Well, let's say you've got your robot super fancy. It's got 16 cameras. You have to, if you want to run a node for each camera to get that data and put it into a topic, you'd have to run ROS run 16 times. Let's say that each of those cameras has a different node in addition to its like initial driver node, we'll call it, that takes that data, processes it, maybe runs computer vision on it, finds like location of an object in the image or something, then publishes it again. Well, now we're at 32 nodes. That's 32 commands. That's a lot of typing. We don't want to do that. So instead, we use something called a launch file. Yeah, you can see. You don't want to run 32 commands. That's boring. We've got a launch file that does that all for you. What it is it's a really fancy way of setting up a bunch of nodes or setting up a system. You can use them, like you can chain multiple launch files together. You can see it's got like a little graph there. You can have one launch file run another launch file. You can have it all be conditional where, okay, let's say I want to run my simulator. Well, I don't launch my camera nodes, but I still need to launch my processing nodes. You can do that with launch files. And you can, so like I might have an argument here that says, okay, run for simulator or run for real life. We have something like that in Rocket League. Which if you remember is the project that I work on in ARC. We're going to move on to the next. Oh wait, there's some extra reading you can look at here if you want, but you don't need to focus on that for this workshop. There's examples. Okay, yeah. So here we've got some pretty good examples of message files. These I can actually walk you through. So, okay, let's say that's the data of where the robot is at the top. You've got a position as well as some IMU data. And so you can see here, okay, that's just numbers. That's integer, float, integer. But the IMU data is another message type that we've already defined somewhere else. And we don't actually have an example of it, but just think maybe it's 3 more floats or something. Over here is another service file. And so this is an example of it, the message, like the call, it sends 3 numbers, and then the response is the sum of those 3 numbers. So that's sort of how a service would work. You'd send data, you get data back. Over here I have an example launch file, and you can see how, okay, so sure I can launch, that's pretty similar to the ROS run command that you use for launching individual nodes, but you can also see, okay, so that looks like the command, but if I go down here, it's got some extra stuff. This is where you can get fancy with launch files. You can do specific stuff, like it's literally Python. You can do anything. It's got conditionals, it's got this right here is where it said, so that's a topic right there. ROS topics are typically like paths. And basically what this part is doing is it's making that node believe that it's listening to turtle sim 1 turtle pose, when in fact it's actually listening to input pose. So it's remapping that topic to another topic for that node specifically. And you can see over here that, okay, this node thinks it's publishing to, or I've got that reversed. It thinks it's publishing to output command velocity, when in fact it's publishing to turtle sim that thing, right? Over here is an example publisher. So remember we've been talking about publishing and subscribing. You can see that, okay, this node right here is creating a publisher that's going to listen to the topic called topic, and it's going to talk to the topic called topic, and it's going to publish a string. So that's the message type right there. And then there's, see, import standard messages. Oh, come on. Import string. And then if I keep going down, there's an example subscriber. You can see it's doing the same thing. So it's got like a callback function for when it receives a message, and it's got, that's the topic it's listening to, and that's the data type. Remember, strongly typed.
So yeah, we will go over like how exactly you create a package, how to like put these files as publisher, subscriber, everything in a package in a bit. But before that, let's go over some cool stuff, right? ROS tools. Like some of these tools make it so worth it that you're using ROS, and it's saved my life so many times in the past. First off, RQT. How many of you guys have heard of Qt before? The GUI 1, 2, 3. Yeah, okay, some of you have heard of Qt. All right, so RQT is basically a version of using Qt for ROS, but instead it comes with a bunch of software that's really useful and a bunch of like programs that you can just like run, right? In your construct sim environment, all the RQT applications are going to open in a separate remote desktop called Guacamole. You might notice that when you ran Turtle Sim. But we'll just go over. But when you have it on your own computer, it's going to launch as a separate window. You're going to see that. So RQT. Let's open. Okay, that's fine. Let's open our ROS check real quick, and this would be on your terminal, on your web shell. If you just type RQT and hit enter. What do you see? Do you guys see anything if you just type RQT?
If you still got your nodes running for earlier, you can use Control-C in the terminal.
Yeah. Let's close the other nodes. So if you run RQT, I mean this should be a separate window, but you should see what I'm talking about. Okay, so this is RQT, right? Under RQT, if you look at the plugins tab, you're going to see a bunch of different stuff. There's visualization. This is a little hard to use. Okay, there's visualization, there's services, topics, robot tools, and so many different things, right? All these you can use to look at what like the camera is seeing, how different topics and publishers are represented, like what is the connection between these two, like. But more specifically, this is one specific command called RQT graph that'll create like a diagram of your entire system, something like this. Currently, we have nothing on a robot, so this is not going to be created. This is an example from an industrial robot we found. And as you can see every single node being connected, how it's connected to the publisher, how those publishers like send certain topics to another node and whatnot, right? So this is like a fully connected, industrial robot. Another version of this specific RQT graph is something called a TF tree. This is something that RQT also helps run. But what a TF tree is think of a let's just think of a mobile. Let's think of a robot quadruped, robot dog, right? The robot dog has its own coordinates in the world frame. Like it has coordinates that it contains in the frame of the entire world. There's also coordinates for each link on the robot dog to its base, to whatever head or whatever the base frame is. So our ROS using TF trees gives us a way to kind of view how all these are connected. You can see what the base link is and what its child is and what that link's child is and so on. So you can have a camera on the end of some link on your robot, and you want to know what the coordinate transform is from that camera to the actual world frame. You can use these TF trees to transform those coordinates with the specific linkage provided with the TF tree to the world frame, instead of actually calculating what the world frame is, calculating that is, and it's a little bit of a mess, trying to go back through looping through each and every single link and finding the coordinates of your camera. Instead, if you just use a TF tree, it makes things easier to just use the camera data as is, but just use a function to just, get the coordinates of separate links. I find TF trees really useful when it comes to using bigger robots with many links or many subcomponents, because it makes this relationship between components in a robot very easy to understand. And if you guys want to read more about it, it uses something called TF buffers. TF buffers are they look like Python dictionaries. They're like JSON files kind of. but at the same time, they have a bunch of other information on every single link of the robot as well. RKT also lets you view like the depth data and RGB camera data. I'm not sure if I can pull it up here. Should be a image view. That's what it's called. Yeah. If you open, I mean, there's nothing right now because if you have any camera connected, it'll show up. But image view basically is gonna like you can select like a specific camera, RGB, depth, whatever it is, and view it on RKT. So yeah, you can also change different like components in your robot. Like for example, if you have a joint state publisher, as you saw in the industrial robot, you can just change like another parameter or some kind of like input to the system on RQT to just test a specific action if you want to. So yeah, that's a little bit about RQT. Do you want to talk about Gazebo?
So Gazebo is, so remember I was talking about a simulator earlier, right? Well, a library I might use to do that is, I guess it's a whole application, both, is Gazebo. It's a physics simulation that comes with ROS. It works with ROS. You can install alongside ROS. It's also installed on our The Construct Sim thing, right? We will use it later. But yeah, that's pretty much all it is. It's a physics simulation with a 3D window, or a window that shows like a 3D view of the simulation that you can like look into. It's great for simulating stuff. It is what it says it is. Arviz?
Yeah, sure. So another component before going into RViz, I do want to talk about another thing here. It's just a note. So the way 3D models, the way you can just represent 3D models in the robots in like or Gazebo or RViz, whatever it is, there's a certain format called URDF, or Unified Robotics Description Format. And URDFs, today there are people who've made scripts for like exporting URDF from like SolidWorks, Fusion 360, and whatnot. And with URDFs, it creates that whole mesh file structure that you need to like import your like 3D model of the robot onto your world, and kind of like just set it up, right? I've put a link over here to show like how these URDFs are created and how you can use them in your environment. But in the end, you'll get something called whatever the name of your file is _description. And that is one of the packages in your environment. So this goes directly inside your source directory. And you can just, when you run like colcon build and whatnot, it'll be able to like build the binaries for this specific like mesh or specific like URDF that's imported in your workspace. And yeah, let's move on to RViz. RViz is a little bit more visual, as the name suggests, than RQT. It provides a 3D environment for you to like view like coordinate frames. If you're using a LiDAR, for example, it shows you like the point cloud as well. Like here's an example from using Spot. That's like Spot's depth cameras from a bunch of angles, and like by default, RViz has this thing where with changing height, it changes the color of the point cloud. So if you want to like see what the height difference is in Z from whatever camera you're using, you can use this as well to like understand how the height changes. And so yeah, I also wrote a bunch about how these point clouds are represented, what format needs to be used if you're interested in doing that as well. But here's an example from I'm pretty sure this is ROS 1, but it's going to be the same like format in ROS 2 at least. But you can view like the live camera stream data from the drone as it's moving around in the environment. So I don't know if you can see the drone here. There's a drone right here, and that's the world frame, and that's the pose that it wants to go to. That's the pose that the drone wants to like move towards. So it's moving towards that, and this is the world itself. So these are all called April tags. Those are used for like 3D localization of robots using like a non-symmetric tag in the environment. And yeah, so that's just an example of what RViz is. In ROS 2, you will use RViz, but it's just called RViz 2 for ROS 2. It's the exact same thing as ROS 1's RViz. It's just named different for using ROS 2. Yeah, that's about it for RViz. Do you want to talk about Move It?
So Move It is something I won't get too in-depth to because it's might not be applicable for everyone. But for those who it is, so what it is it's inverse kinematics. It's an inverse kinematics framework. You'll see it a lot in stuff like robot arms, where, okay, let's see, your node knows that you want your hand to be here at this time, but it doesn't know how to actually move it there, how to like change the motors, how to actually physically move the hand of your robot arm to be there. That's what you'll use Move It for. It's great for motion planning. Okay, yeah. I won't get too much more in-depth into it, but I definitely recommend reading about it if you're working on like a robot arm or something similar.
Like many like research teams and like big companies like Google, NASA, Microsoft, they like, if you want to work on their robotics teams, they like to see like experience in like Move It and ROS and all that too. And yeah, like there's some images here as well. You can just go through those.
Yeah.
I also want to mention one more thing though. One sec, sorry.
No, wrong thing.
No, you're good.
I always said that escape button.
So there's one more thing here that I found really cool. Foxglove Studio. Remember how I talked about ROS bags? How you can record ROS bags and just like, what do you call it? View it as how the states change in your robot. Foxglove Studio is, in my opinion, like my favorite for using, like, you know, if you have like a bunch of recorded data on the environment and you want to view it all in one, use like 3D recording, 2D camera recording, whatever it is. Foxglove Studio gives you that like, you know, that environment to like just play the ROS bag from start to finish and also see every single topic in a streamlined manner. And if you have like LiDAR or whatever, they have different formats. Just view the LiDAR in different colors, so you can see like where the camera is in 3D space along with all the topics. It's just a free software that I recommend using. Yeah, it's pretty cool. So yeah, do you want me to talk about the stuff? Yeah.
So we have 40 minutes left.
Yeah, so we have time. So it's fine. So before moving on to the mini project that we're going to start doing in a bit, I want to talk about what it actually means to use ROS, right? Why do we need ROS? Like, what is it? Why is it so important that so many different people are using it? And there's been a couple of debates in the past, but like more recently, it's just accepted that ROS is the framework for robotics as well. So if you can go through some of these examples, but I want to look at this specific thing right here. So this one specific article from I think there's a company in Netherlands called Purdue Robotics. They mentioned why don't they use ROS, and they mentioned if you look at their robotic system, it's just a very specific application called it's just a little like aluminum trolley. It's very basic, right? It has a bunch of like ultrasonic sensors. There's a LiDAR. It also has an STM32, I think. Yeah, so it's an STM32 along with a couple Raspberry Pis on board. So it's a pretty simple system, but it's also a very specific application to just move heavy objects around. And that's what they're made for, right? And they made a whole article about why they don't use ROS and why it is inefficient for them and how like ROS itself would, you know, like would be useful for them in the future, but they don't want to use it, you know. So this sparked a debate in the robotics community. This is ROS Discourse, by the way. That's the forum for ROS enthusiasts. And there's this one specific person, Construxim, right? He is the person that, like, Construxim is the company that, you know, built what you're using, right? So they basically published a whole article in response to the Purdue Robotics article. talking about why ROS is, like more useful, and most of it is just stuff we've discussed in the workshop. So they talked about, how SLAM, autonomous mapping, it's so much easier to work with ROS for such applications, and solve for problems is something that they mentioned as well that are easier to like debug without ROS. But clearly, if you have a larger robotic system with many subcomponents and something that makes it easier to like look at your robotics project from different components, ROS is the way to go. And there's a postdoc here from Purdue. His name is Kshitij. He also like wrote about a couple alternatives to ROS. If you have just a small, simple robotics project and you don't want to get into ROS, there's also another thing, right? So the whole point is getting into industry, robotics at least, if you want to like get into that area of things and show that you've worked with robots for in this professional setting, and even getting into research, if you want to like use your ROS expertise on deploying it on real robots, bigger robots, ROS is the way to go. It is by far the accepted industry standard, and it is, in my opinion, also like it is also the easiest to like control like a complicated robotic system. So yeah, you can read some of these articles if you want to, and have your own arguments about this. That's totally fine. But yeah, so with about half an hour remaining, we're going to start the mini project, right? You guys can get your laptops open. So there's two mini projects we're proposing. You can do either one. We personally prefer the first one because it's pretty much, it's pretty set up for the most part, and all you'll be kind of doing is trying to change the controller, write a publisher, subscriber, and whatnot, right? So the first one is like you'll be setting up a ROS workspace from scratch for like controlling the Turtle bot. This is not the same as Turtle Sim, right? Turtle Bot 3 is the little 3D robot you might have seen in the ROS background. It's this robot right here. So that's a Turtle bot. So you'll be using that Turtle bot and write some scripts to control this Turtle bot. And that would include, like writing a publisher, subscriber, to understand like how you get data from the Turtlebot. A Turtlebot has a LiDAR in it, so you can even use the laser scan and a bunch of other stuff that you can like. You'll be able to like just go through documentation and try to find out, right? So there's this one command that you might have to use before running the Turtlebot. Yeah, you can go ahead.
So when we say that you want to run Turtlebot, probably doesn't make much sense at first, but Turtlebot it comes with, so it's a physical robot, right? But like any robot using ROS, it's also got simulation. And we're going to do a simulator that runs in Gazebo. I can't type on that. Can I type on this? There we go. That's better. So I won't give you everything, but I'll give you some hints. There's 3 nodes you're going to want to run, or launch files and nodes. Gazebo. So that's file Turtlebot 3. I don't have these memorized. So that's one launch file you're going to want to run. What that'll do is it'll open the simulator, which is Gazebo. So we've technically already given you the command for that. You just need to fill in the blanks, right? Another one is teleop. Scroll a little bit.
Is it done? Yeah. I'll pick Turtlebot.
So that's a launch file. And then you're going to, so once you've actually got the simulator going, it doesn't have like controls at first. It's just a robot. If you want to control it, you have to use your own code. But for testing, there is another Turtlebot 3 teleop. Node name. Turtlebot 3. Teleop. Key.
The file is saved through your key.
It's different on the
Oh.
It's different. So I'll show you. So on the Notion, there's the name of everything, so you can copy and paste, right? Now that's not actually, you're not running code there, but you're getting the simulator running. If I go back here and close a bunch of stuff out, I'm going to show you one more trick about Linux, and that's, can I stick here? Okay. So once I've got, that's fine, it's fine, because I was just going to show tabs. I've got that command running. I've got that command written, sorry, right? But I don't know what the rest of it is. I don't know, like, okay, I've got turtlebot 3, but what's inside that? Well, if I want to, I can hit a space. You can't see it. That's not very helpful. And then keep typing, and then I can hit tab, and okay, the construct sim is kind of slow. But if I hit tab enough, eventually it'll show up a list of the possible launch files that I could use for that part right there. So you can, it's like autocomplete is what it is, if you know what that is. So you'll want to use that in case, you'll want to use that to find the, I have to refresh, find the node and launch file if it doesn't work. But other than that, you should technically have everything you need to get started. We've talked about publisher and subscriber. Remember, there was the example stuff. There's the example code in like step 5 or something.
We can go through creating a package.
Creating a package, good idea.
So, I'll like if you guys want to know about how to create a package, I can just do a little mini tutorial right now. That is something we've linked in the Notion, but let's just go over it in person. So let's go to my workspace, which is an empty workspace. You can just click on build here and see there's nothing in here, right? So from the workspace, you can just directly, do you want to go up a little bit? This master package, great. Yeah. So, okay. Here you want to go into the source directory. Once you're inside the source directory, you'll see there's nothing. Here you want to create a new package. So the command is ROS2 package create, and then you need to add some, like, what do you call it, build files to this. So it's just build type. It's Ament Python, I think. Is it Ament Python? Yeah.
Remember, all this is already linked in the Notion, so you
Yeah.
don't have to like copy over there. You can just copy and paste from that web
Yeah,
page.
and you can just search up creating a package if needed. Creating a package on ROS2 Humble on the web browser, and you should be able to find this. And then you want to name your package. So let's just say turtlebot control, right? So you want to write a package to control your turtlebot. Actually, there might be something called turtlebot control, so just to make it easier, I'm just going to call it TB control. So this would automatically create a new package inside your source directory called TB control. And if I go into TB control, you'll see there's a bunch of like setup files, you know, package.xml, and so on, right? And this is a specific package for which you're gonna like, you know, create the files for. So inside of this, you can create another directory for scripts. Is that what we're calling it? Or
Depends. It's like where you put your code.
yeah, do you
Yeah,
want to?
scripts work.
Okay, yeah, we can just call it scripts for now. And inside of scripts is where you want to do all this. But now, it might seem like we're doing a lot of work on the terminal. There's so many like sub files and so many directories. This is where you want to go into your code editor and work from there instead. Because it's easier. It's just a VS Code emulator. So let's open my workspace, source, and we have TB control. This is a TB control like package. Inside scripts, you want to make a new script. So yeah, do you just want a new file and then publisher dot. Yeah. Let's call it publisher.py. And then let's create another one as well called subscriber.py. So this is a publisher and a subscriber. For this, you can actually use the publisher subscriber we gave you before from the ROS examples. And yeah, we need the launch file, right? Do we need the launch file?
Yeah, you can just run it technically with
Yeah.
Python 3.
Yeah. So yeah, you can go ahead and just look through what we've given you, look through the documentation, and we'll just walk around. If you have any questions, just ask us. So.
One more quick thing, you'll notice that like when you go to the example publisher and subscriber, they each subscribe to and publish to specific topics. And okay, let's say you don't know what the topics are for the Turtlebot off the top of your head. There is a GitHub. There's a GitHub repository with all the Turtlebot code that I'm going to put on the mini project page. And so you'll be able to go there. Maybe you could look at, okay, if I can control the robot using my keyboard, using the turtle teleop node, maybe I should look at the code for that and see what topic it publishes to, see what message type it uses. Mm-hmm. Yeah, we'll put that in the Notion. I think I can do that from here.
Yeah, if you refresh the page, it should show up as well. We'll put the GitHub. Do you have it? Yeah, you can just set a bookmark. Yeah.
I'll figure that out later.
Yeah, for me, I can just make it a bookmark. That's fine.
And there's also a
Yeah, I made it a bookmark.
All right, you'll want to refresh to get both of those pages.
Yeah.
I'm gonna walk.
Yeah.
So, if you open the Git repository, go first to scroll down, go to the first one. So that's where you go. So it's like a stamp. So let's go to Turtlebot 3 example. And inside that, let's open the source document. Yeah, so let's open Turtlebot 3 example. So Turtlebot 3, there's so many different files, right? For you personally, like this, this might seem like a lot of different sub-components, right? Like, this is how it's actually supposed to be like used how you use a Turtlebot, right? But we've given you ROS examples, right? So if you just go online and search up Turtlebot 3 example ROS 2 or something like that, it should show you that. What we're trying to do is we want to just make a publisher and subscriber that says, so this is moving with this much, it's moving forward with this much, it's moving right with this much. And one of it is going to receive the command, like, it's going to receive command saying move forward, move back, move right, whatever. One of them is going to receive command saying, send the command saying move forward. Yeah. Exactly. So something called keyboard tally. It's already built. It's already like there.
Under the example code, or it's just like a function.
Yeah. So open your constructs and look. Or you want constructs? Yeah. So now just go to your workshop. Yeah. So just So let's do ROS 2 space. Launch. ROS 2 space launch.
Oh, this is the more script.
Yeah, this is not the launch script exactly. This is just a Robot3 underscore
say turtle bot free polyop keyboard.
Yeah.
Yeah, so they released that.
Just so you guys know, the second node package, the what do you call it? The node name was wrong. It was intentional, kind of, just for you guys to figure it out. But this is actually supposed to be a keyboard. But like, it was supposed to run into